atoms are neutral particles because the number of electrons moving around the nucleus equals the number of protons in the nucleus. However, this is no good for the atoms as they all want to achieve a complete outer shell full of electrons, or stable electron configurations, just like the noble gases. Now, this is done by either losing or gaining electrons. This means they are no longer neutrally charged and are now called ions. This concept is best explained using examples. Looking at sodium with an atomic number of 11 has 11 protons and 11 electrons. It has 2 electrons in the first, 8 in the second, and a lonesome electron in the third. Not only that, this electron is the furthest away from the nucleus, so it's the least tightly held. It's pretty sad. He should just leave. In fact, because the attraction is quite weak, this electron is easily given up. And because the sodium atom has given up one negative charge, it is now positively charged. Now, this reaction can be represented by an ionic equation, where the charge on the ion represents the imbalance of positive or negative charges. Overall, metals tend to form positive ions. These are known as cations. What about chlorine? It has an atomic number of 17, so 17 electrons in 3 shells and 17 protons in the nucleus. 2 electrons in the first, 8 in the second, and 7 in the third. Now it only needs 1 more electron to achieve a noble gas configuration. Therefore, the chlorine atom will accept an electron, giving it an overall negative charge. Now this reaction can also be represented by the ionic equation. Nonmetals generally accept electrons, and these are known as anions. Hydrogen is a bit of an anomaly. The hydrogen ion is more commonly formed as opposed to the other one. Because of this, it's often placed on its own. Such a maverick. The combination of anions and cations lead to an ionic bond. The charges gained by these ions allow an electrostatic attraction, a bit like a north and south pole of a magnet because opposites attract. This ionic bond decreases their total energy and allows them to achieve a more stable state. But remember, a cation will attract all neighboring anions and vice versa. As such, ionic compounds lead to an empirical formula, that is, they show the simplest whole ratio of cations and anions. In the case of sodium chloride, it's a 1-to-1 ratio of sodium cations and chloride anions connected in a 3D lattice structure.